Hi all, I am Divya Somakumar and in this video we are going to learn about ROC curve and AUC curve. Now let's begin by understanding what exactly is ROC curve. ROC curve is receiver operating characteristic curve is a graph that shows the performance of a classification model at all classification thresholds. It's a curve that plots the relationship between true positive rate and false positive rate. It's a probabilistic curve. A small history about ROC curve dates back to the World War II times when the soldiers identified whether a threat from the enemy is a false threat or a true threat using ROC curves. Now let's learn about the concepts which are embedded inside the ROC curve. The first concept is true positive rate or your recall. What exactly is recall? It tells us about how often the model predicted that an individual is affected when they are actually affected. True positive upon true positive plus false negative. Our recall is also known as sensitivity. The next concept that we learn is specificity. What exactly is specificity? It tells us how often the model predicted that an individual is not affected when he is actually not affected. Specificity is equals to Tn upon Tn plus Fp. Now, what is false positive rate? It is nothing but 1 minus specificity. Now, let us understand the concepts of recall, specificity, false positive rate using a graph. Consider the following problem statement. What is our problem statement? To identify whether a person has diabetes or not. Now on our x-axis we have our observations, on our y-axis we have our probabilities and a threshold. The yellow line is the threshold which is by default kept at 0.5. The orange dots that you see indicates that people have diabetes. The green dots that you see are people who do not have diabetes. Now, when the threshold is at 0.5, all the points or the orange dots above the threshold, these are true positives. And the points below the threshold, the orange points below the threshold, these are false negative. Here, people actually have diabetes, but the model predicts that they do not have diabetes. This is false negative. This is your type 2 error. This is a grave scenario. These people actually have diabetes. They have to be administered insulin, but our model fails to predict that they have diabetes. Hence, insulin is not administered to them. This is a life-threatening scenario. Now, how will we overcome such a scenario? We can overcome such a scenario by reducing the threshold. Now when the threshold falls to 0.3, your true positive increases. Now all the orange dots are classified as people having diabetes. But you have a catch over here. Your false positive also rises. That is, people who do not have diabetes are predicted to have diabetes. So your false positive rises and your true positive rise when you reduce your threshold to 0.3. Now, what happens when we increase the threshold to 0.6? Here, your true positive decreases. Greater number of false negative and your true negatives are high as it is. Now, let us understand the same graph using specificity and sensitivity. So you can see a graph over here. This green curve shows your true negatives and your red curve shows your true positive. Here you have your specificity. What is specificity? A person who actually does not have diabetes is predicted to not have diabetes. What is sensitivity or true positive? A person who actually has diabetes is predicted to have diabetes. Here, when these two curves overlap, we have false negative and false positive. So basically, a person who does not have diabetes is classified to have diabetes. Here in FN, a person who has diabetes is classified or predicted to not have diabetes. Now, to solve this problem, we changed our threshold from zero point 0.5 to zero point 0.3. So now when we reduce our threshold from zero point 0.5 to zero point 0.3, what happens? True positive rises. The area under sensitivity curve, that is from orange line to this end, sensitivity rises. Your true positive rises, at the same time your false positive also rises, but your false negative falls. Now if the threshold is at zero point 0.6, your specificity rises, your false negative rises, your true negative also rises. So to summarize, when your sensitivity increases, your specificity decreases. When your specificity increases, your sensitivity decreases. And the relationship between true positive and false positive, when true positive increases, false positive also increases. So you have an upward sloping curve. Now let's look at the best fit curve. So best solution is when these two curves, your true negatives and true positives, are not overlapping each other. There is no error in this case. This is our best fit line. Now let's learn about ROC curve. Now when we plot our ROC curve, which is nothing but the relationship between false positive rate and true positive rate, we get an upward sloping curve. Now, what is AUC? AUC is nothing but the area under curve. Now, when your AUC is 0.5, that is 50%, our classifier is not doing a very good job. Hence, it is the worst fit line. Now, when your AUC increases to 0.7, that is 70%, our classifier is doing a good job. We want our AUC to be 100%. We want our curves to be very close to 1. So, this AUC curves can help us determine which model is good for prediction. I hope the concept of ROC and AUC is clear for one and all. Thank you.